In this video, I'll be helping you with the Aleks problem type called determining the location of a terminal point given the signs of trigonometric values. In this example, we're asked to find the quadrant in which the terminal side of theta lies, and we have two conditions here, A and B, and for each I'll reference back to the unit circle. Starting with A, we're told that the cosine of theta is less than 0, so we'll recall that the cosine of theta is our x values on the unit circle, and less than 0 means that our x values are negative, so that would be everything on the left side of the y-axis, where x's are 0, but we're also told that the cotangent of theta is greater than 0, and here we should recall that cotangent of theta is cosine over sine, or x over y. And so for x over y to be greater than 0 or positive, the signs of x and y must be the same. In quadrant 1, both of those signs are positive, so the cotangent is positive. And in quadrant 3, both x and y are negative, so x over y is positive. And since we have to meet both of these conditions, the only place where they overlap is in this quadrant 3. So for A, theta must be in quadrant 3. Looking at B, here we're told that the secant of theta is less than 0. Secant being 1 over cosine is less than 0, means that cosine must be less than 0. So x is, again, negative here. So the left-hand side of the unit circle. And then the other condition is that sine of theta is less than 0. And since sine of theta is our y values, for that to be less than 0, y must be negative. That would give us everywhere below the x-axis where the y values are 0. And for this example as well, even though it was described differently, the overlap is again here in this third quadrant. So for both of these examples, they're describing thetas that would fall in quadrant 3.